This video is about connections of identical batteries in parallel and in series. It is also about connections of identical solar panels in parallel and in series. Please do subscribe to the channel and continue to watch the video as I go into the details of what the combined or resultant ratings will be when identical batteries are connected in series or in parallel, and also when identical solar panels are connected in series or in parallel. Moving on, just as the topic implies, solar panels and batteries, series and parallel connections. We have four cases here. The first case is where we have two identical batteries in series. The second case, we have two identical batteries in parallel. The third case, we have two identical solar panels in series. And the fourth case, we have two identical solar panels in parallel. Here, in this case 1, the capacity of each of the batteries is 100 ampere hour, then 1280 watt hour at 12.8 volts. So, and these are the resultant ratings. That is the ratings after the combination. So, taking on the first case, when two identical batteries are connected in series to form a battery bank, capacity in AH remains unchanged. Individual capacities in watt hour add up, individual voltages add up, same current flows through the battery that form the battery bank. So, and that is why here we are having the ampere hour capacity of the resultant of the battery bank so formed being 100 ampere hour, equal to the ampere hour capacity of each of the batteries. Alright, and the voltages are adding up also. So the watt hour capacity also add up as indicated here. So now the second case, which is B, where we have the batteries in parallel. So when two identical batteries are connected in parallel to form a battery bank, individual capacities in ampere hour add up. So the ampere hour, this and this will add up to give 200. And also individual capacities in watt hour add up also. So 1280 watt hour, 1280 watt hour will give 2660 watt hour. Then voltage remains unchanged. For parallel connection, the voltage of the battery bank itself will be the voltage of individual batteries. Then individual currents add up. So that is what will happen. The current of this one will add up to the current of this one. And that is the situation for now. Now, to prevent the danger of short circuit, in this case, where we have identical batteries in series, a fuse is provided. Alright, and the size of this fuse will be determined by the C rating of each of the batteries forming the battery bank. For instance, if the batteries are lithium-ion battery and each of them having a C rating of 1C, so 1 times 100 ampere will give you, that is 100 ampere. So this one tells us that the maximum power, the maximum current that can be drawn from the system is 100 ampere. It should not be more than this. So in this case, if we have lithium-ion batteries, the fuse here will be of a rating of 100 ampere hour. If the batteries are lead acid type whose C rating is 0.2, then the maximum current that can be drawn from the system in series there will have been 0.2 times 100. So this 100 is the ampere hour capacity. So it will have been 20 ampere. So the size of this fuse will have been 20 ampere. So it has to be taken note of. It's very important. So here F1 is a fuse and we have fuse here. We have fuse here since we are having these ones in parallel. So each of the batteries we have is its own fuse, and the size of the fuse will be determined based on the C rating of the battery, as I mentioned earlier. Alright. Now let us take up the third case, when two identical solar panels are connected in series. Then individual powers in watt add up, just like we have here. 100 plus 100 will give us 200 watts. Individual voltages add up. 20 volt plus 20 volt will give us 40 volts. Current remains unchanged. The same current will flow through the system, this current I. Alright, then we go to the fourth case, where we have two identical solar panels connected in parallel. So these are the resultant ratings. So when two identical solar panels are connected in parallel, individual power in watt add up. 100 watts plus 100 watts will give us 200 watts, just like in this case. Whether parallel or series, the powers will always add up. Individual currents add up. The current of this one will add up to the current of this one. 5 amp plus 5 amp will give us 10 ampere. Individual currents add up, we have done that one. Then voltage remains unchanged. Since the two are in parallel, it is the same voltage that will be across them, so the voltage does not change. Now let me talk about the sizes of the fuses. Before I talk about this situation, and I said, assuming these batteries are lithium-ion batteries with C rating of 1C, 1 to be multiplied by 100 ampere to give us 100 ampere, and that will be the size of this fuse. So you multiply this, the C rating, with the capacity in ampere hour, and you get the value of the current. That is the maximum current that the system can take, or that the battery can give out. Alright, so the same thing is applicable to these batteries here. But in the case of solar panels do not have C rating. So when we have identical solar panels, two of them connected in series like this, the size of the fuse will be slightly, the protective fuse will be slightly greater than 5 amperes. So 10 amp will be okay for this protection, for this fuse F3 here. And in this case, the same thing, 10 amp will be okay for the fuse here, 10 amp will be okay for the fuse here. In the case of series connection, we have only one fuse protecting the whole system. But when we have parallel connections, each solar panel we have here is own protective fuse. Generally, one can note that when we have identical batteries connected either in series or in parallel, the capacities in watt hour will add up. 1280 plus 1280 will give us this. And when they are connected in series as well, parallel as well, the capacities in watt hour 1280 will also add up to give us 2560 watt hour. So whether series or parallel, provided that they are identical, the watt hour capacities will add up. So in this case also, when we have identical solar panels connected in series or in parallel, the power will always add up. So that's why we are having increasing watt power here, just like here. So 200 is the addition of this and this, and in this case also the same thing. Furthermore, and conventionally, when batteries are connected in parallel like this, the input or the output cables are usually connected to the same battery. The positive cable and the negative cable are usually connected to the same battery. That is no longer the case, or that is not the case here. And the reason is that it has been observed that for improved efficiency or for a better efficiency of the system, the positive cable can be connected to one battery, while the negative cable will be connected to another battery, just as we have it here. This one ensures or guarantees that one battery doesn't do more work than the other. So, and therefore, none of the battery is put at the risk of being quickly damaged. So the same thing goes for the situation when we have two or more identical solar panels in parallel. The positive cable is connected to the positive terminal of one solar panel, while the negative cable is connected to the negative terminal of this solar panel. That guarantees a higher efficiency, and it also ensures that no solar panel does more work than the other. And that is the end of the presentation. Please do subscribe for more. Thank you very much.